Talking all about combustion in our Live Science Stage show today. Before we get started, does anybody already know what combustion is? Does anybody have some ideas? If you do, you're welcome to shout it out.
It's a study of fire.
Yeah, fire. We're talking all about fire today. Combustion is the chemical reaction that gives us fire. So we're going to be talking about fire, some of the ingredients fire needs, and then how we can use fire in our forests. So before we get started, do you guys want to see some combustion? All right, I'm going to count down on 3 when we do combustion. Okay, ready? All right, 3, 2, 1. Wait for it, wait for it.
Whoa!
Was that exciting, you guys?
Indeed.
More of that coming. All right, we'll do one more. We'll do one more little demonstration before we jump into our brief safety talk. Just to give you a couple different depictions of combustion at work. Right, there's lots of different sources of fire in nature. All right, I'm going to count down on 3 for this one as well. All righty. 3, 2, 1. Sound a little cooler? Maybe? Depends on who you ask. Those are just a few examples of combustion or fire at work. But as fire is a very powerful, important force of nature, it's important we're safe around it, right? It's important for kids to be safe around fire?
Yes.
Yes. What about adults?
Yep.
Also yes, right? Everybody's got to be safe around fire. So that's why all the demonstrations, all the experiments you see today, I've practiced many times. I know how to do them in a safe and controlled way, right? I've been trained how to do them. I also have a few extra safety tools with me. I have a fire blanket up here, and I have not 1, but 2 fire extinguishers. So a couple extra tools to make sure we all have a safe time. You'll also notice on the floor I've got some nice cones. What side of the cones do you think we should stay on? That side, right? And I'm going to stay on this side so we can all have a fun and safe time. All right, now that we've got the safety part out of the way, we can start talking again about our little triangle here of combustion. Does anybody know how many sides are on a triangle? 3, right? And we are looking for 1, 2, 3 ingredients. So to get us thinking about what the first ingredient may be, how many of you guys have been camping before? Couple campers? All right, awesome. So if we pretended that we were all on a big camping trip together, right? We've got our stuff set up, it's getting a little dark, it's getting a little cold, and now we want to make some s'mores. If we want to make some s'mores, what do we got to build before we get our s'mores roasted? A fire, right? So if we were in the woods trying to build a fire, what's in the woods that could maybe help us build that fire?
Logs?
Wood, right? Sticks, right? Lots of great things. We got leaves, moss, all sorts of dried materials, right? Organic materials that we can use as fuel. Does that sound right? Fuel might be an ingredient for fire. Just like our cars need fuel, right? We need some fuel for combustion, something to burn up. So like I said, there's lots of great organic fuels in the woods. We're going to try out a few different inorganic ones today. So for my first one, I got a little bit of metal. Now thumbs up, thumbs down. Do we think metal's a good fuel? I've seen a lot of thumbs down, right? Normally it's a bad fuel, right? That's why we got a nice metal tabletop. Because I can hold a flame up against it. It's not going to catch on fire, right? Because most of the time, metal's not a great fuel. But I've got a very special metal here today. This one is called magnesium. Can we say magnesium?
Magnesium.
Magnesium, that's a big word. All right, this is a special type of metal that I have heard is very reactive, so it should be a good fuel today. So what I'm going to do is I'm going to give our fuel some energy, because combustion reactions don't just happen out of nowhere, right? They need some energy to get them started. So I'm going to hold this in the flame to give it some energy from the candle. And it's going to take a second here to reach that activation energy necessary, but once the reaction starts, I'm going to ask that you don't look directly into the light, okay? It's going to be very, very bright, as you can see. You can kind of look at the floor, you can look at the TVs, at me. We just don't want to stare directly into that light. So we don't want to hurt our eyes. Yeah, it's very, very bright. So combustion reactions are exothermic, meaning they give off energy. Normally that's in the form of heat or light, and for magnesium it's a very, very bright white light. So that's a reaction we don't see in the day-to-day. I have a couple more fuels to try out here. Do you guys normally think it's a good idea to go around your house seeing what's a good fuel? No.
Probably not.
Trick question, no, right? We don't want to do that, but we're going to do it in a safe and controlled way, right? I know how these fuels are going to react. I know how to handle them safely. So for this next one, I've got isopropyl alcohol. This is a liquid fuel. Thumbs up, thumbs down. Do we think this is a good fuel? Yeah, I would agree with the thumbs up. So let's try it out and see what happens when we add some isopropyl to the fire. All right, 3, 2, 1. You think that's a good fuel?
Yeah.
I would say so. That looks like some good combustion right there. So I've got a couple extra bottles here. And what we've done with these ones is we've added some metals into them. So they still have isopropyl fuel. We've added a couple metals. So for this first one, I've got copper sulfate in here. So let me know if you notice anything different when we add some metal to our fuel. All right, 3, 2, 1. Ooh, that was a little tiny. You guys see some green, some coloration there? It's pretty cool. All right, so for this one, I'm gonna give you the chance to guess. I've got strontium chloride in here. What do you think we're gonna see?
Pink?
Ooh, that's a good guess. Let's try it out. All right, 3, 2, 1. Ooh, red. Yeah, that one works a little better. Our copper gets all built up in here. Should we try both of them together, red and green?
Sure.
All right, let's see. 3, 2, 1. Ooh, there we go. Just a little bit of green, a lot of red, some orange from the fire. All right, so those are a couple fuels we can try. So that's our first ingredient, right? We need some fuel. That kind of makes sense to me. We need something to burn up. So to get us thinking about our second ingredient, I'm going to start us off with some fuel. We're going to put a little bit of isopropyl alcohol. This one's isopropyl alcohol, 70%, and then 30% water. So we're going to mix that around. As we saw, isopropyl is a pretty good fuel. Now for our second fuel, what do we have here? Ooh, nice $5 bill. Cool. Maybe we should burn this? Is this a good fuel? Raise of hands. Who wants to burn this? Who wants to commit a felony? Ooh, only a couple. Okay, who doesn't want to commit a felony today? Ooh, okay, well, I'm going to use my executive power, and I'm going to say we're going to burn the dollar bill. So I've got my nice dollar bill here, which is made out of a blend of things, including cotton, which is a really great fuel. So we've got two really good fuels here, so we should get some good combustion. I'm going to mix this all around. I am making it soggy, but I'm making it soggy with isopropyl fuel. Right, so let's see. We've got a couple good fuels here. I'll wipe off a little bit of the excess. And I'm going to count down on 3 again. 3, 2, 1. Ooh. Oh, that burned out pretty fast. Should we add more fuel?
All right.
Maybe. Let's repeat our experiment here, see if that happens again. It's always important when we're doing science to have multiple trials, right? Make sure what we're seeing is not a one-time thing. So I left a little bit more fuel on that. Let's see what happens. Ooh, okay. It's a little better, but it went out again. Do you guys remember what else was mixed in here? What did I mix with my isopropyl? Water, right? What does water normally do to fires?
It puts it out,
right? So what are waters doing here? Once all the fuel's burned up, it's cooling down the dollar bill, it's drawing out that energy, and it's stopping the fire. So luckily, our $5 bill is in one piece. We have not committed any felonies today. All right, so if we're thinking in terms of ingredients, right? If cold things stop fire, what do you think is going to help fire? What would be the opposite of that? You can shout it out if you think you know. I heard a good guess. Hot, right? We need some heat. Like I mentioned earlier with the magnesium, reactions need energy, and heat is a form of energy, and that's normally the source of ignition for combustion reactions. So we need some heat, right? Heat and fuel. So let's see what we can do with just 2 out of 3 ingredients, because that seems pretty good to me. So what I'm going to use first for our fuel ingredient is I've got some lycopodium powder, and it's got a nice flame on there because this is super flammable. And this is actually an organic fuel. It's made out of dried moss spores. So we've got some lycopodium powder. That'll be our fuel. And then for our heat, I'll use a little match here. So we've got a lot of fuel, and we're going to add a little bit of heat, some ignition to that fuel. And we'll see what happens with just those two ingredients. All right, you guys? It's a lot of fuel. Okay, ready? 3, 2, 1. Oh, nothing happens. So we're missing our third ingredient, right? We need all 3 ingredients. That's why it's a triangle. We need all 3 of them to get some good combustion. So to get everybody on the same page about what that third ingredient is, I'm going to do a quick demonstration here to show you guys and get you guys thinking about what our third ingredient is. So I'm going to use some lycopodium powder because this is actually what we used in our first little demonstration here. So I know it works as a fuel. I've seen it happen. So I've got a little bit of fuel in my hands, and we're going to use the matches for the heat again. And then I'm going to do some fire bending. I'm going to do our lycopodium throw, all right? So I'm going to throw this fire on the count of 3. You guys are going to duck. Just kidding. All right. 3, 2, 1. You guys want to see that again?
Yes.
All right. I'm going to do it one more time. Sounds pretty fun. And I'm going to give you guys a little bit of a hint. I heard some good guesses earlier about what our missing third ingredient is. So here's my hint for you guys. When we add just the fuel and just the heat, we didn't get any combustion. But then when I'm throwing it in the air, we get some good combustion. So maybe think about what's in the air. That might be helping our little reaction here. All right, I'm going to count down on 3 again. 3, 2, 1. All right, you guys have some guesses in mind? I'm going to count down on 3, and everybody give me your best educated guess. All right? 3, 2, 1. Oxygen. Very good job, you guys, right? We need some oxygen, which is in the air all around us, thankfully. It's what helps us breathe. It's also what helps fire breathe, right? Fire really, really needs oxygen. It's super, super important. So we're going to do one more demonstration before our finale to show you guys just how important that oxygen component is. So for this one, my fuel of choice is going to be a nice cotton ball, right? Earlier we burned the dollar bill made out of cotton. What is a cotton ball made out of? Quick quiz, I said it a couple times. Cotton, right? Good job, you guys. Cotton's a great fuel. It's also what our clothes are made out of. A lot of our clothes are made out of cotton. So if I put this in the fire, it's going to catch on fire, right? Which is not super great for this cotton ball. Also not super great for those of us wearing cotton clothes. But do we know a safety tip if we ever get our clothes caught on fire?
Stop, drop, and roll.
Yeah, stop, drop, and roll. So we can do that with our cotton ball. We can stop, drop, and roll around. It's a little hard with the tongs, but you can see that put the fire out pretty fast. It's still burning a little bit, but when we removed the oxygen from the surface, it stopped the fire. And then inside, nice white and fluffy, right? That's you if you stop, drop, and roll, okay? Remember that. That's also why we have our nice fire blanket. If we have a smaller fire, we can smother the fire, remove its access to oxygen, and hopefully that'll put it out. So that was a little demonstration of the stop, drop, and roll rule, but I have with me a different cotton. And this one's called flash cotton. And what makes it so cool is we've added extra oxygen. So we should get a different reaction from this. All right, I'm gonna count down on 3. 3, 2. Oh, that was pretty fast, you guys. I barely had to touch the flame. All right, I'm gonna count really, really fast this time. Ready? 3, 2, 1. Oh. I wasn't even fast enough. Just barely. All right, ready? 3, 2, 1. Okay, there we go. All right, now if we're really quiet and the dinosaurs are quiet, I'm gonna use a big chunk of flash cotton, and we might even be able to hear it. All right. You guys hear that? That was a pretty big chunk. So as you can see, right, when we add the oxygen to the combustion reaction, it helps it burn brighter, faster, and louder. So now that we have all 3 of our ingredients, I think we're ready for the finale, the whoosh bottle. All right, yes, this is my whoosh bottle of fire. All right. So if I want to create a nice, awesome, fiery explosion, what is my first ingredient? You can shout it out if you think you know it.
Fuel.
Fuel, right, you guys? That was the first one we talked about. We need some fuel. We need something for the fire to burn up. Or for the energy to burn up. So for my fuel today, I'm using isopropyl alcohol. If you guys remember the spray bottles, that was a really good fuel. So we're going to do about 40 milliliters. Oops, I put 45. That's okay. Let's put more. Alright. Yeah, we're going to make a huge ball of fire. Don't tell my boss. Okay, so right now our fuel is sitting in a liquid form at the very bottom. This is not great for our reaction because I'm going to put the ignition right at the top. So what I'm going to do to solve this is I'm going to take this bottle and I'm going to spin it around a whole bunch of times. And what that's going to do is it's going to turn this nice liquid, it's going to evaporate it and turn it into a gas, which will mix with the oxygen, which is also in a gas form. So we should get a nice volatile fuel. It's going to take me a second to mix this around. So I normally like to take this time to talk to you all about ways that you can light things on fire as a job that are totally safe and totally legal. Right? One of the first ones you could do is you could be a chemist. A lot of chemists do combustion reactions. They work with fire. You can also be a science teacher, right? A lot of science teachers do combustion reactions similar to this. You could even be a firefighter, which sounds a little silly, right? Normally firefighters stop fires. But sometimes firefighters that work in the woods, they actually start fires. They do small, controlled, prescribed burns. And what those burns do is they clean up all those little bits of fuel, right, that are in our forests. So that when a natural fire comes through, they don't have as much fuel. They don't burn out of control. So that's a really important part of land management in a lot of our natural spaces. So I'm going to mix this around a couple more times, and then I think we'll be ready for the whoosh. Before I do the whoosh, are you guys okay if I turn the lights off?
Oh, yep.
Alright, I'm going to cut the lights so you guys can see it a little better. Alright, I'm going to give it a few more good shakes. And then I think we're ready to add our last ingredient. Alright, so if I have fuel and if I have oxygen in here, what's our last ingredient we're missing?
Heat.
We need some heat, we need some energy. So I've got this very fancy shielded lighter here in case our fireball gets too crazy. Alright, I'm going to count down on 3 for this. 3, 2, 1.
Whoa.
Alright, that was our whoosh bottle. It went pretty fast. There's a lot of fuel in there, a lot of pressure. Thank you guys for sticking around to see that little